now. Should I start? Can I start? Okay. Hi, everyone. Welcome to another PyLadies event. I will be hosting the community announcements. My name is Öykü, and I'm not really a good public speaker, so I'm quite excited. Bear with me here. Thank you. Okay, so today's agenda is quite exciting. We have two talks and a showcase of data. So first of all, we will hear from our lovely host, Bettermile. And afterwards, we have a short non-coding superpower talk contributing to open source, followed directly by the scikit-learn's metadata routing API. And then we will have a short break. We will have something to eat, drink, socialize, networking, and then we'll continue with writing a custom scikit-learn estimator, which is very exciting. Then followed by predicting delivery risks with machine learning, trust courier innovation. And then we will have some time for chat and we will close the night. But what is PyLadies at first? PyLadies is a mentorship group, international mentorship group for marginalized genders in tech. We are focusing on helping our community become more active participants and/or leaders in the Python open source community. And of course, all skills are welcome, no matter what your level is. And our mission is to promote, empower, educate, and advance a diverse Python community through outreach, education, conferences, events like this, and social gatherings. We aim to provide a friendly support network for gender minorities and a bridge to the larger Python world. And over the years, we managed to have awesome speakers from all over the world. And there's not just PyLadies Berlin, but we are basically everywhere. PyLadies Berlin was founded in 2013 with nearly 4,000 members, or 3,163. And it's like growing every day. We have 4 chapters in Germany, which is also growing. And we do regular monthly meetups with talks, workshops. Sometimes we organize full-day workshops. We set up events to get started with coding. We connect people to companies, and we also try to be active in the conferences, and we do some kind of raffles and everything. Yeah, anything you can dream, we can try to make it happen. We follow a strict code of conduct. We believe knowledge is for all, and at the same time, our events aim primarily to empower gender minorities in the tech community. By attending one of our events, online or real life, you also agree to our code of conduct. If you see any harassment or any disrespectful behavior, you can reach out to any of us. We definitely do not tolerate that. Also, we take photos during the event to share in our social media. If you want to opt out, it's definitely fine. You just let us know. You can also do it now by raising your hands, or you can find us later on. Say, hey, I don't want to be in the photos. It's totally fine. Okay, next meetings. There's also another event in February about scikit-learn again, quite exciting. In March, there is Humble Data Workshop for 2 days at JetBrains. And also, aside from PyLadies, PyData Berlin is organizing a January meetup in January 15th. Next day, there is PyLadies Hamburg. You can join through hybrid, through online as well. And on February, there's PyBerlin AI Night with a panel session. You can also create your own PyLadies avatar through this link. You can customize it, actually. You can give the different hair color, different accessories. It's quite fun. It was a community project. Yeah, so you can join us on PyLadies Global Slack Workspace. How to do it is that you just sign up through slackinpyladies.com. You accept the invitation, and then you join City Berlin. What else you can do? You can give a talk. We definitely need speakers like you. It doesn't have to be only coding or tech related. We also have non-coding superpowers topic, like 5 minutes, like lightning talks. You can talk about presentation skills. I definitely need one. Convince your colleagues, asking stupid questions, and so on. It's always nice to have one. What else you can do? You can give a talk or a workshop, help us organize a meetup, join in the organizing team, like get involved, or be a coach at one of our workshops. Okay, rest up our speakers. Should I introduce now? Okay, sorry. Before our community, host, welcome. I'd like to go through our speakers. Marine, she is a machine learning engineer at Deutsche Bahn. No, not Deutsche Bahn, sorry. Is it Deutsche Bahn? Okay, sorry. Deutsche Bahn. Okay, thank you. David Zestel, I don't know how to read, but Scikit-learn team member, Narwhal's team member, and PyLadies Berlin co-organizer, which is very nice. Thank you. We have Stephanie, open source developer at Probable. Stephanie is an open source developer at Probable, contributing mainly to scikit-learn with a PhD in history centered in solidarity movements. She made a career shift into tech, bringing a unique interdisciplinary perspective to her work. Also, thank you. We have Tamara, open source software engineer at Probable and compiling NLP researcher. Tamara is working on ML explainability, interpretability, and fairness. She is a maintainer of FairLearn and a scikit-learn and Scopes contributor. Tamara works as an open source engineer at Probable. Thank you. And lastly, we have Claudia, data analyst at Bettermile. Claudia is a data analyst at GSL Studio with a strong interest in machine learning and data engineering. With a PhD in mineral physics, she switched from a career in geo and planetary science a few years ago. Her goal is to strike the perfect balance between technology and science. Thank you. And Helen transitioned into the field after achieving BA and MPhil in linguistics, where she was first introduced to language models and Python. Her prior experience spans business development, social media, and community management and marketing, equipping her with a diverse and well-rounded perspective. All very nice. Thank you all for our speakers. And before you go, I would like to also mention that you can give us a feedback on this workshop and register as a member of PyLadies in following links and also the QR code. Thank you. Now the welcome talk.
Hey, welcome. I should stay here probably. Welcome, very nice to see you here. I'm Vitalia from Talent Acquisition at Bettermile, and it's a very short talk, I promise you, and you will get to the data talks. We'll just talk about who we are, what we're doing, about our smaller sister GLS Studio, and about our open roles. So what we are doing, we are offering software as a service for the last mile delivery, and we are fully baked by GLS Group. We are growing, we are over 100 people now, very diverse team, specifically proud of over 40% of female, and we are still working on that. We are very data heavy with a lot of parcels processed on the last mile, a lot of tracking requests from consignees who are expecting their parcels. We support the delivery drivers on their routes, and we're making their life easier. So that's our product suite. BetterRoute is a dynamic sequencing app for delivery drivers on the last mile deliveries between the last depot and you when you shop online. Then we have API with location intelligence. It normalizes addresses from senders and reach with geocoding. There is tracking. We all love to see where our parcel is. And back office is a component for depot managers. And that's JLS Studio. We are working very closely together. They were created 2 years ago, and already have 16 people in there with 2 products piloting. Actually, Claudia and Helen are from JLS Studio, not exactly from BetterMile. And we have 2 openings in their team. So if it looks like an interesting challenge for you, it's senior data engineer and product owner. Welcome. Thank you. You will find people from BetterMile with these tags. You can talk to us. You can get in touch with us through career page. You will also find QR codes with LinkedIn page and career page on the walls. And enjoy the show.
Okay, so now we're gonna come to the lightning talk. So I'm gonna talk about contributing to open source projects within 5 minutes, how to get started. So first of all, let's talk about the motivation. Like, why would you wanna contribute to open source? Why is it a good idea? So first of all, it's really good for your skill development. And it's also really nice to give back to the community. So maybe at your job, you're using a certain open source project and you would like to give back to that open source project that you use for free. So giving back is really nice. And once you get a bit more experience, it's also really nice to helping others grow. It's really rewarding. And it can also be great for exploring your interests. During your work, you may not be able to explore your interests so much, but within the open source world, you can really explore anything, which I find really nice. It's also really helpful with building a professional network. People are often very experienced within the open source world, so having that network is really great, especially when you're looking for a new job. And you also get feedback from highly qualified people, which is really nice because that really advances your skill development. And it's also really nice for building a public portfolio, which you can show, for example, when you're applying for a new job. And so now that we talked about the motivation, let's talk about the different ways of contributing to open source. And this is a non-coding superpower talk, so we want to focus not only on coding. And in fact, there are many different ways of contributing to open source that many people don't think about. For example, you could organize events like workshops, or sometimes also called sprints or meetups or conferences. That's really helpful. Also, if you're experienced in designing a good user experience is really helpful for making a project more accessible and therefore increasing the likelihood of making it more successful. And it's also really important to do public relations, like, for example, managing social media accounts. That can be a lot of work in itself as well. Also something like newsletter writing or documentation, documenting code, writing examples. That's really helpful, actually. And it's also really helpful to do basic management. So like labeling issues, watching them, closing them. That's also a lot of work in itself. And then finally, you can also contribute code, and I'll briefly go over that. So if you decide that you would like to contribute code, first of all, what you need is a GitHub account. So most of the open source projects are hosted on GitHub. So first of all, you need an account on GitHub. And then once you have that, I recommend that you go to First Contributions. This is an open source project hosted on GitHub. And this project basically guides you through how to make your first contribution to an open source project, in this case, the First Contributions open source project. And it guides you through that step by step with screenshots, and it's really nice. And then you make your pull request, and then there's a bot in the background that automatically merges your pull requests. And yeah, it's a really great project for learning how to do all of that. And it's available in many different languages, which is great. And so once you did that, so by the way, I also got started with this. And so once you do that, it's recommended to read the
contributing guide of open source projects, because there you will find all the information you need for setting everything up, and also supportive material, for example, video resources. Here on the right-hand side, you can see an example from scikit-learn. Here, the contributing guide is called Developers Guide, and you can, for example, find it under the More tab. And then once you are through that, what you want to do is go to the open source project that you would like to contribute to, and every open source project has a tab that's called Issues, and then you click on that, and then once you are there, you go to Label, and there you can look for different kinds of labels, and what you want to look for is, for example, a good first issue, or easy, or documentation, or something like that, and that these are then good issues that will get you started. And that's the end of my talk. So thanks a lot. And these are my social media handles in case you want to connect. I can just
I'm live. All right. So, welcome. I'm Stephanie, and I'm so nice to be. I'm so pleased to be here. So, thanks for having me for this talk. I'm an open source developer at Probable, which is a company that is operating open source projects such as scikit-learn and some others like Fairlearn or Jobleap and a few others, and makes sure that they keep up to date and like state of the art, and that is also offering some services and some products to make your data science life easier. So I'm working there in the open source team, and I'm contributing to scikit-learn. I started with that 1.5 years ago when I did an internship at scikit-learn. And there I was first introduced to the topic of metadata routing that I'm talking about today. So this was a very long process, and a lot of people have been involved. I'm just seeing Adrian sitting behind in the back, who designed that thing, and I helped implementing it into scikit-learn. So before that, I was in a phase of career transitioning, and I participated in a data science bootcamp, and then I started teaching there. And even before that, I was an historian, and I was working on transnational history for solidarity movements or on solidarity movements. So, and I'm always happy to connect. I will also be here at the scikit-learn sprint that is going to take part in February. It was mentioned in the beginning, and I'll be happy to see many of you there again. So, okay, so today's talk will be on metadata routing. So basically, metadata routing is some new feature that we've been implementing in scikit-learn. Let me just ask the audience, so whom of you has at least once in their lives used scikit-learn? Okay, that's like 80 or 90%. So for those who don't know scikit-learn, it's an open source library for machine learning, and we provide estimators, like models, that you can use, and also tools for model evaluation or model selection, and a few other things. And like with the metadata routing, this is a new feature that is still in experimental stage. And we are very happy if people start using it, and this is why we start presenting about it. If you, during the talk, have some small, quick questions that will match to what I'm just talking about, then just raise your hand. I will try to repeat what you've been asking for the audience on live stream. If I forget it, please tell me. And otherwise, there will be some Q&A section in the end. So, and we will share the slides afterwards. So there will be some links, but you will get them afterwards. All right, so now starting with the topic, what is metadata routing and what is metadata and what is routing? So metadata routing API, this is a fancy term that we invented in scikit-learn. We hoped that people would know what it is, but still it's worth explaining. So it's the name of a new feature. It's almost fully available since May last year, when we had released the 1.5 version. In the meantime, we had 1.6. And as I said, it's still in experimental stage, so meaning you have to enable it when you want to use it. And later on in the talk, I will show you how. All right, so what is metadata? So metadata can be any data that you want to apply on top of your usual tabular data. And it doesn't need to be part of it, it can be, but it can be extra. Like it is always extra, but it also can be a part of it. Let's say it like that. So an alternative way to think about metadata is that it is something that you want to pass to an estimator besides from X and Y. And looking at some examples, if you've been using scikit-learn, you've probably come across sample weight and groups. This is almost the only type of metadata that we have there. But other libraries, such as Fairlearn, they use other kinds of metadata. And as you will see during the talk, that these could also be integrated with scikit-learn, because now there's a new metadata routing API. And finally, you could also implement your own metadata. You could invent it, or you could design it. You could use it for your own business logic, and design it the way you need it. Okay, the benefit of using metadata is not that you will have better scores on your models. Probably not, maybe, probably not. But instead, you will have a better model and a more accurate model to begin with. Accurate in the sense of more fitting reality in this case. So, and what is routing then? So routing is just a mechanism to pass the metadata that you're using around to where you would actually use it. So, or like in this lingua of metadata routing, we talk about consuming metadata. Or when you want to, like an alternative way to think about it is when you think about functions, those would be quarks that we just pass to be used somewhere else. So I'm trying to make you understand what the new API is useful for. So before the metadata routing API, there were certain problems, and in 5 minutes, I will show you some of these. But just summing up, so there were certain functions or metrics that would be able to consume sample weight, but we couldn't use them in a more nested structure. It was just broken, it didn't work. And with the new API, the advantage is that now we can pass sample weight or groups through several layers of nestedness, and we can also use other libraries, estimators or metrics, together with scikit-learn pipelines, for instance, or together with other scikit-learn tools, and you could still use their metadata. It wasn't possible before. And the new API also allows you now to define your custom metrics, and you can even make your own estimators, as this is the point where Tamara's and my talk link. So this is why I'm emphasizing on it. So you can make your own estimators with your own metadata, and you can integrate them with scikit-learn, and everything works if you follow Tamara's instructions that she will give you later on. All right, setting the stakes high. Okay, so now you want to see some examples and some code. So, so imagine that this is some data on a study that was studying the effectiveness of a medical treatment. So our target is the recovery time, and like the lower the recovery time, the better, and we want to find out. All right, so when you now look at this, there are two things you can do. So you can, in scikit-learn, and I will present you with both. So you could use sample weight to rebalance the data in a specific way. And you could use groups to prevent data leakage if you evaluate your model in a cross-validation setting. So, and I will explain both in case you haven't heard of them. So groups, let's start with groups. So you see these hospital icons here. I hope the remote people also see my cursor, I'm not sure. So you see the blue hospitals, the black ones, and the orange ones. Okay, so this is a way to show that the data comes from different hospitals. So just imagine that every sample is a patient. So we have a data that is kind of assembled from different hospitals. So it is not so far-fetched to assume that this data has some systematic biases due to the fact that it comes from different hospitals. So these hospitals probably have different policies that they comply to, because they might, like we are in Germany, they might be situated in different states. So they might have different medical devices, or the socioeconomic status of the patients could be differently distributed. And there might be hospitals that have a certain type of specializations and the others don't have this type. So in this scenario, we could use the groups of the hospitals. So we know where the data came from, like those different hospitals. So we use the provenience to make a new param that is called groups, like that. So you see the groups are, the groups are some indicator of which hospital the data came from. So we have the group blue, the black, and orange. So these, as you see, that the input shape of the groups is like the same as the number of samples and 1. All right. And you can also see that this is not, like the groups is not connected to data. It's not integrated into the rest of the data we train on, but it's something extra. It's kept separate. Okay. And in scikit-learn, we, for a long time, had a tool that could use those groups, even without the new API. So it's called, now, come on. I will show you in a moment. Come on, it's called, it doesn't matter. I will show you. So if we use this groups in a specific kind of group splitter, this was the name. So we can split the hospitals for cross-validation in such a way that we don't repeat hospitals from the same hospital in both the training set and in the validation set. So when we cross-validate, basically we are interested in the real performance of the model. So if patterns exist in the data, which in this case it's very likely, then we don't want to leak those patterns between training and validation set. So, and the tool is, as I said, need to go down, is called group kfold. And this is a splitter that we can use in cross-validation, and it's automatically taking the groups into account, and it has been like this for a long time, even without the routing API that I'm going to talk in a moment. So how this works is we have a rich, and we want to cross-validate on this rich, and we define a specific kind of splitter, which is called group kfolds, and then we pass the groups to the cross-validate, and then it splits the data in this specific way that I've been showing here. All right, so this has always worked, but when we now talk about sample weight, so let's start the same way we started with groups. So let's start with talking about what sample weight is used for, and then we will try the code thing. So what is it for? So we can use sample weight to draw a model's attention to a specific subgroup of the samples. So we might have seen that a specific subgroup is underrepresented or misrepresented, and we can use sample weight to counterbalance that. Because you imagine that in an ideal world, we have data that is this is kind of the gold standard. It would come from a randomized trial, and the conditions are very constrained, but this is not what machine learning is made for. So it's made for actually real-world observation data. And this is mostly what we are working with. So more realistically, we have this kind of observational data, and then there might be biases, and we can use sample weight on top of it, just as we used groups. And it will help reduce this bias. So, and how to create or how to engineer sample weight, this is a very complicated thing, and you have to have a lot of domain knowledge in order to know how to do it. So when we talk about the example, about the medical study on the effectiveness of the treatment, then it could be that we observed that some feature like sex or race has been misrepresented, or not like we think it's occurring in the world. So in this case, we can use sample weight for rebalancing. And also another use case is if we suspect there's some kind of correlation between the fact if some feature, for instance, let's say it would be race, and the fact if a patient got a specific treatment at all and would appear in a certain way in this data, then we could also use sample weight. And this has a name. It's called inverse probability of treatment weighting. And in the end, there's some links, and there's a really good blog post that explains what it is if you're interested. Okay, so if we assign a higher sample weight to a specific subgroup of the samples, the effect will be that it's minimizing the error on the training these samples get. So the model is more specialized towards these samples, but why not just train on these samples separately? So we still want to take the whole richness of the data into account. This is why we only weighting and not excluding. So, and in the links at the end, I also have a very good video of Vincent Warmerdam, who's also working at Provewell, and that's a 10-minute video you can see on this topic. Okay. So now let's talk about the coding part of sample weight. Okay, we're just trying to do the same thing as before. So we know that rich.fit is able to consume sample weight. And if you use it individually, you can actually pass sample weight and it's taken into account. If we try to just do it the same way, pass sample weight the same way and to cross-validate as we did with groups, well, it doesn't work. We get a type error. And this is because before the routing API, we just couldn't do it. Scikit-learn was not prepared for that. All right, and this would be even a more real-world scenario because you just don't want to cross-validate. You actually want to nest something in order to so it's useful. So in this case, let's just talk it through. So in this case, we also want to cross-validate. We want to cross-validate on the grid search. And this grid search is searching some params of rich. And we've defined a custom scoring. I mean, it's not so custom, but it's our own scorer. And we also, again, use the group scaffold. We know it consumes groups. And we know that rich can consume sample weight. So we try to pass sample weight, but it's not a surprise. We will have the same type error because scikit-learn wasn't prepared for that. So now there was a lot of work done on this topic, and now it's possible. So in this last part of the talk, I will tell you how. So let's get to the next slide. How? So I just want to draw your attention that it's actually what we just talked about. This is the same code, and this will grow a bit, and we will see how metadata routing works. So this is the same code. There's just a little difference down here that we pass. Where's my cursor? So that we pass params in a different way as on the previous slide. All right, but there's a bit more that we need to do. So the first step is that because it's still in experimental stage, we have to enable metadata routing. Like in a few versions from now, this won't be, you won't need this anymore, but right now you need to enable it with this code. You import scikit-learn and set the configuration to use metadata routing. Okay, then the next step. So this is interesting because there's some smart main idea of routing is that we will have some top layer tool to interact with. So in this case, our top level tool is cross-validation or cross-validate. It could be pipeline, it could be stacking regressor or whatever you want to use. This is just the example to use it on cross-validate. So cross-validate will get all the params that we want to route, all the metadata that we want to route with the params keyword argument, and you just pass it like this. As I said, like groups is much more easier to engineer than sample weight, but let's say you have this, it's the right shape, you can pass it. All right. And the last step is this one. It might look a bit strange, but it's easy to explain. So these are the so-called set method request methods. And you can see that actually they're not called set method requests, but actually the method in the middle, you would substitute by wherever you want to route it to. So in this case, let's see if I can now find my cursor for people in the live stream, but I don't find it, doesn't matter. So you see up here in the third line with the rich, we want to set the request on fit because we want to route sample weights to fit. So this is why we set the fit request. And below at the scoring, we set the score request because we want to route sample weights to the scorer. And then, as before, group K-fold automatically recognizes or automatically accepts and needs to accept, it needs it to function, the groups. And this is why we don't need to set it. Don't worry, it will become easier in future. So these are the 3 steps. So we've enabled the metadata routing, we've passed the metadata to the top level tool, and we've set the requests to where the metadata is consumed. And then that works, right? You can now use your cross-validate and use the scores and no type error anymore. All right, I will encourage to every one of you who's interested to try it out and play with it a bit, because it's a very powerful tool. Because if you want to have more like fairer and unbiased, less biased models, this is a good tool to use. Actually, the only one scikit-learn offers at the moment. Okay, so just a little outlook on the future. So there's that we expect with the next release sometime in summer, that we expect that metadata routing will have full compatibility then. At the point of talking, there's only one, like it's only AdaBoost left. So if you want to use AdaBoost, that's not available in metadata routing yet, but everything else you can do. Also, like in the future or right now, we are defining some default settings. So in the future, you won't need to set all these requests because we are thinking of ways to make defaults that are most useful to the users. So we will still keep flexibility, so you can change it by setting the requests in a different way, but there will be defaults and it's easier to use then. This is why I said it's becoming easier. All right, so that's been it. These are the links that I promised. So I want to draw your attention on the first 2. So we've got a user guide that explains metadata routing, how to use it. And in case you are like after Tamara's talk, you want to write your own estimators. So there's also a developer guide, how you can integrate metadata routing in your own estimators if you write some. And the links that I've pointed you towards during the talk are also here. And that's it. So now it's time for your questions. And thanks for your attention. So, yes.
How one can become an intern in scikit-learn?
Okay. The question was how you can become an intern at scikit-learn. You can apply. So we've got still internship programs, and yes, I don't know when it's next. Adrian knows more about that, about the plans. You want to talk? You want to say that? So we are still getting new interns. 2 of them will start very soon, and I think it's summer. Adrian, you know more.
So we got a CZI grant, a Chan Zuckerberg grant, which gives us 2 interns for up to 2 years. One person we have already found in Paris. She's going to start. and I'm in the process of launching for one in Berlin. So we will be getting one person for ideally like up to a year very soon.
Right, but the question is, can you still apply?
And how? And
When I open it, there will be a page where you can apply to.
We don't know when.
No, that depends on when I get to do it. It should be in the next couple of weeks.
where can they find this information? When it's going to be posted? That's the question.
My LinkedIn, Probab's LinkedIn, Scikit-Learn's social media, and the main channel would be PyLadies, because we advertise it through the PyLadies, and then that you can ask Maren.
Nobody knows.
All right. More questions? Yes.
So in your example, could you actually pass different sets of groups? Or can you only pass like one group, or is it a set of groups that you could use that as well?
You can only pass one. I mean, you can be smart and engineer it so it fits still. Because you can if there's a group and there's another group and they don't overlap, you can intersect. And then it's more different kind of groups, but you could engineer it. Yes. Okay. Something else? Or from the remote people?
There's someone online saying, very interesting. I recently used this feature.
Oh,
It's
cool.
a game changer.
It's a game changer. Nice. It's not a question, but like the best thing you can hear.
I thought you'd like it.
I
But
do.
there are no questions.
Okay. So yeah. Any more questions? Doesn't seem so.
All right, then.
Okay,
another
thanks a
huge
lot.
round of applause. We will have like 5 minutes break, so please don't go too far, but grab a drink, use the toilet. We'll just test if the microphone is working also for like the setup that we have for the stream. And then we will go on to our next talks.
Hello, welcome. Please sit down and welcome. The joy of estimators is going to start soon. Is it okay? Okay, I have to keep going because we're testing the microphone and we have to see if it echoes, but I'm not going to tell you about estimators yet. And I'm not very good at telling jokes, so you just have to look at me. Is it good?
It sounds good. Maybe anybody online can tell us if it's okay for them, if you're watching online. And in the meantime, we'll just have to turn your camera on.
Isn't it? Hello. It is not the joy of estimators, but it is. I'm going to teach you how to write a scikit-learn estimator. My name is Tamara. It's going to be a presentation that is going to teach you the minimum of what you need because we have only 20 minutes. So we're going to rush through it a little bit. So as I said, my name is Tamara. I'm here mostly in the role of open source contributor and maintainer. This is where I got the idea or where I have been dealing with estimators. And I work as a software engineer at Probable. Stephanie works with me and she already explained what Probable is. I work with her in the open source team, but I do have a different focus. I work mostly on Fairlearn, which I will introduce really briefly at the end. And I also do computational linguistics research as part of a degree I started a while ago at the University of Potsdam. And I'm a bit more involved with that in the next few months. So what are we going to talk about? We're going to talk about what estimators are as a concept. Maybe some people don't know what estimators are in scikit-learn. Why would you write a custom estimator? We've got a few reasons. Mostly we're going to hold on to how to write one through an example that I copied from the documentation. And I will give you an example of what I did with custom estimators in the library I maintain, but it's going to be really brief. So when you leave this talk, you will definitely not know all the tiny details of the API and the conventions, but you will have the big picture, and every slide that introduces something new in scikit-learn that you haven't seen is going to take you further, so there will be links. So when you leave, you will know where to look for more information about everything I say. And just a note before I continue, although I have contributed before to scikit-learn, it's been different things, and I have not been involved in writing this API. And I've mostly interacted with it as a library maintainer and in a library that tries to be fully scikit-learn compliant. So you will feel that in the talk. Unfortunately, I think my talk is a bit longer because it was just the minimum I could fit, and there might not be time for questions, just so we honor the next talk properly. But everything you see on the slides, you can approach to me to ask me if it's practical. I can open a notebook, and if it's theoretical, we can talk high-level stuff. Yes, and now that was about me, and I'm going to ask you about you. Who works as a machine learning engineer or data scientist or whatever are now the titles that people use for those things and uses this kind of concepts that we're going to discuss in everyday work? Oh, you do not count in this talk. Adrian is my colleague anyway. Stefan introduced him. He knows a bit too much about this topic. And who has written a custom estimator today without, except Adrian? Has anybody written one? Has anybody thought of writing one? Martin has. Okay, it has never come up in a company kind of discussion or let's make our own estimate. It has. Okay, that is really cool. Do you want to share about what was the use case? I don't want, or too much on the spot. That is also fine. Okay, in the domain of property prices. Okay, so let's see what estimator is from the very beginning. So then the term estimator comes from statistics, and where it's a term for finding the estimate of an unknown parameter given some data. I give you here a definition. But basically, this estimator is the method. The estimator is the method for finding the value we are looking for the way we will estimate. And in practical terms, if we think about targeted ads, because I couldn't think of anything else, we can get some customer data that we have access to about a particular customer. We can run a classification algorithm on that data, and it will tell us which of the already thought of targets or groups for these customers this customer most likely belongs to, so we can serve them the targeted ad that belongs to that group. And the classifier in this case would be our method to achieve this and our estimator. In scikit-learn, there are 207 estimators, and they're the scikit-learn's predominant object. And if you look at the documentation, they are defined as an object that fits a model based on some training data and is capable of inferring some properties of new data, which is this in essence. This that you see here, sorry, I don't know where my pointer is for the people online, but the all estimators is a function that you can call at any time and see, it will list you all the estimators that scikit-learn has. And if you learn it, if you count, you will get 207. That's today. I don't know about any other day if something's cooking. So if scikit-learn has 207 estimator across all of the use cases you can think of, like a wider range of problems in statistical machine learning, they are maintained, picked by experts, rigorously tested for the statistical properties or otherwise. Why would you want to implement your own? And I have 4 reasons, but you might have more. One, for example, would be that it's a specific use case that you have, or your use case is small, and you want to create an estimator for it, but you also want to use all the other tools that scikit-learn provides, or the compatible ecosystem, which is quite large. Another one would be if you're like me, a library maintainer, or somebody that wants to offer estimators to the world. I think it would make sense that you want to make them fully scikit-learn compliant and scikit-learn ecosystem compliant, because this will increase adoption and ease of use. You might want to write a meta estimator that Stephanie mentioned, and meta estimator is basically an estimator that does something with another estimator. That in practical terms would mean that you want to bundle up a few steps before or after a specific estimator, for example, transformations on data post or pre-processing, and you interact with the estimator with those additional steps as one, and you can integrate it as such in pipelines, which can be really convenient in some cases. And the very last one reason I could come up with was that you want a very new method. And as a researcher in the NLP area, I know that there's just so much coming out every day. And some of these methods might be very interesting for your specific use case, and they're not in scikit-learn yet, or they might never make it there. First, because it takes a long time to merge something as significant as a new method and needs to be vetted and properly programmed to be there. And another thing is that not everything that will come out will make it to the library. There are only 207, and we know that there is so much more in the world. And this is because some editorial decisions need to be made about what goes into a library. And the bloat versus the maintaining load has to be taken into consideration. So now finally, how to write one. This is I copied this from the documentation, because first I wrote an elaborate example and then I changed my mind about taking this 20 minutes for that. It's just from my editor, that's why it looks different. It's taken from this link. This is the most important link of this presentation, because this is the link that has all the details, and we'll go through everything I will say and more, because I won't be able to even to go through all the minimal things that might be interesting. And another great reason to visit it is that you will also find templates there. You'll find templates for different kinds of estimators that you would want to write for different kinds of problems. basic testing setup, and so on. So that might save you tons of time. So what we will do with this code that you see now, you see the whole code without comments that I will add in the next slides. We will disassemble it basically line by line, more or less, and we're just going to talk about it, what's in the line. So we start with the very beginning where we define the class. As we can see, we are inheriting from base estimator and classifier mixin. Classifier mixin should always be on the left at the beginning. So we could actually write a custom estimator without these classes, but what they do for you, they would specifically base estimator will sell you tons of boilerplate code and will maintain sync with the scikit-learn library changes, which do happen. And also we'll make sure that its compatibility is maintained and it fully exists. So it's recommended that you use it, but maybe you have a reason not to. And the classifier mixin, it's called like that because we are implementing a classifier. As you can see, the name is template classifier. It's a classification problem, and that's why the mixin is called as such. And there are several of these for different problems. Like, for example, if you're doing a regression, if you're trying to solve a regression problem, you'll have a regressor mixin. Then you have cluster mixin. And if, for example, if you have a transformer model, which is not the NLP kind, but the kind of that takes some input, does something with it, transforms this away and outputs it, that will be a transformer mixin. And in these cases, in every single case, you have to implement fit that you see there. But the function here, we have predict, and that is because we have a classification problem. But if we had, for example, a transformer mixin, this would be a transform function. So you have to make sure you implement the right methods. Yes, and in the classification case, you could also implement something like decision function or predict proba if it's applicable and you want it. Okay, let's expand this a bit more. So after the definition and the basic structure, we have the constructor. And the constructor is very simple intentionally because this is all that it is supposed to do. The constructor should not do anything else than set the parameters passed to it. They should ideally be keyword arguments with default values, and it should stick to things like hyperparameters or parameters that describe the model behavior. And they also should be preferably non-mutable objects, and there is a reason for this that's connected to cloning, but you can achieve this if you really want to pass mutable objects. You have to check the documentation for this. It will take a slide. I had to remove it. One important thing is that you shouldn't pass the training data here, and there should be no logic, no input validation on your parameters, and no changes. So really just take and set, and that is it. And if you write in the estimators, this is the only way to set the parameters. One other way would be to use estimator.setparams, which base estimator will give you automatically. You don't have to write it. That is if you want to change them later in the process. Then we look at fit. Fit, it comes with every estimator. I will remind you of that. And this is where we do the learning and training. And so fit takes only the training data and the metadata. I don't have it here because this is in documentation. I don't have it, but ideally for people in the stream, next to the X and Y, there will be a quark sort of, so we can take anything that comes out. So it's the metadata. I don't have it here. And here's where you do the input validation, which is this check XY function that you see. There are multiple of those, and I'll have a slide specifically for those because I really wanted to talk about it. Some more important things is that there is a convention that you put a trailing underscore. You see the classes and X and Y have a trailing underscore. This is because we learned these, or we set these parameters in fit. And the last most important thing is that it returns the classifier itself and returns self. Now, there are a few other things. I grayed them out because I talked initially about them in detail, but it was really too much. But since we're looking at a classifier here, for example, it would be really important to set the classes. It is necessary. Our checks are going to complain about it, where you put the unique labels, the label names. I will share the slide so you can see all these other details, and they are in the documentation. But it's to keep in mind that there is a bit more to it. Then there's predict. the last method we're going to talk about. And here we check if the model is fitted. This is also part of the validation scikit-learn module. You can just import it. You don't have to write it. Then there is input validation. This is another function called check array from the validation module. And at the end, you do your prediction, whatever that is for you. Now, that is the minimum API with some exceptions that I couldn't talk about. And it's pretty small, but this can extend in any way that you'd like. As a summary, the most important thing is that it would be nice to import for base estimator plus the appropriate mixin for your problem. Here we have a classifier, so we have import from classifier mixin. In the init, in the constructor, you just set the parameters and you don't do anything else. No logic, no input validation. Fit must be there, and it just takes the training data plus the metadata and returns the estimator. And you would need to implement something like predict or transform according to your mixin. And this will already set you quite a bit. Now, I wanted to ask a quiz, just so you're not falling asleep. What is this predict here? What kind of classification is this? I have some comments to help you, but it's not. What classifier is it? Is it too small? Yes. I have here so you can conveniently stare at my typo to distract you from. Does anybody know? Which classifier would this be? I mean, it's fair because there were not so many hands for the for people that do this every day. Maybe some of my colleagues want to say. Yes, that is true. One and or the k-nearest neighbor with just one, just because we're getting one. One is when there will be one minimal here, the closest distance label that we're returning. And this is where our classifier did. Okay, so input validation, because I really wanted to talk about it, is quite. I really believe that these functions are really underused for the real benefit that they provide. I've seen from other people that the most used function is check array that you also saw in predict, where we only have an X, but people also use check XY when they want to do validation in both. They differ in multiple ways. And there is another one that's called validate data, which I mostly use these days. It was introduced as a public function in December when scikit-learn 1.6 came out, and does some additional nice things for your estimator setup, and that you get to skip if you use it. So if you're writing custom estimators, that's something you want to do. And why would you want to use such strict input validation, or you want to, this is important, is because not all estimators accept all kinds of data, and you want to make sure that the data you're passing works for the estimator on your use case. And another really nice reason is that there is an interplay between these validation methods and the estimator checks and estimator tags I will introduce in the next 2 slides that will help you with keeping the quality of your modeling more rigorous and maintainable, if you ask me. So these first 2 links are how to and just scikit-learn actual PI file with the validation methods that I mentioned. And this is a video that will explain the first 2 for you. Doesn't have the last one. And I spent so much time looking at these. And in my use case, when I was trying to make the estimators compliant for the library I work, these were saving the day several times, and they were the answer by setting some settings there. And I even found a repetitive pattern of usage, and I got to add a little validation thing to one of them. So it saves you a step when you're dealing with non-negative values. So please check them out. The last 2 things are the estimator checks. And these are your friends. They will perform common checks and determine if the custom estimator is compliant with the API and guidelines. So you could start by getting this example that I just showed, and then you have the estimator checks enabled, and then you check if it's fully compliant with what the API and guidelines that I mentioned are there. And you can also use a fixture called parameterize with checks to achieve the same. And I really think that they are a great way to find all the missing pieces and strengthen the estimator quality that you're building. And they really help with making your estimators compliant and keeping them. And the last piece of the puzzle that I will mention is estimator tags. And what they do is they describe the expected properties of the data, the expected estimator behavior, etc., and you add them at the like this as part of your estimator. Oh, it went off. Do not know.
Okay, well, we still hear you.
Yes, I will now speak louder so you can hear me. And these tags are used by the common estimator checks, these, to make the checks even more, even better and checking right for what you need. And they're also used by isRegressor, isClassifier, which are two other methods. They can be extended with custom tags. And one important thing is that if you have used the tags before, they look different. There was a different API, and this is the API from Scikit-learn 1.6. And in the third link down in the bottom is from a library created by some of my colleagues that there is an example how you can make this compliant for the old and the new version. And as a library maintainer, this was a lot to think about. And checking this library called Scikit-learn Compat will make your life much easier. Okay, so I rushed through this to keep the 20 minutes. But how I got into this topic of custom estimators in such depth, this is because I started to contribute to FairLearn last spring. And some of my first tasks were making the library more Scikit-learn compliant in multiple ways. But I did start from the custom estimators that we had. We had a few, and I think running the estimator checks returned 700 errors then, the first month when I started. And because Scikit-learn is FairLearn is a toolkit for data scientists to improve the fairness of AI systems. That means that being easy to fully integrate into existing and new Scikit-learn pipelines was really crucial to make people use it. It's not so easy to make people use fairness tools. So yes, I still am involved in maintaining this library, and there's a link there where you can find us. We're always looking for new contributors, and we're going to also be part of the Scikit-learn contribution event next month if you want to give it a go. And yes, this is the work. This is just a part of it. There was really a lot to be done, and it's not over, as I spent the last week ping-ponging with one of our new contributors about introducing a new estimator, and we need to make that compliant. Some of these PRs you can see are very simple. I don't know, some of them, I guess, they have one commit and 4 comments and so on, but some have 27 and many files and so on. And some are simple, some are complex, but they all brought up interesting conversations. We got to refactor a lot of the code and reconsideration of how we write it and for the future. That's why I say that the estimator checks and tags and validation all help to build more robust and better estimators. And there was a really steep learning curve for me. So I had to learn the intricacies of both libraries as I was doing this. And I didn't know both of them at the time. And if this scares you now, I just have to say that if you're doing this for in a company or for your personal project or anything that is not, you're a library maintainer, you want to be really full compliant so people use your fairness tools, this might not be so rigorous. You can skip some of these estimator checks. There is a way to do it, and it's in the API, and so you don't have to make it everything. And some of them, actually, it's a good thing to mention that some of them are general, and yeah, they might be an error, they might return an error, but to your specific use case, they might not, it might not really count so much. You have to know your problem really well to make this decision. Okay, and this is my last slide. The idea for this talk, besides doing this constantly, came from me when I heard that writing a custom estimator is currently part of the syllabus of the Scikit-learn expert certification that the company I work for offers. And my thought was that I really want to bring this topic then to the PyLadies. And one of the reasons is because machine learning and AI expert are terms that are really thrown all around. They can be very intimidating, and their meaning can be very gate-kept. So you have been now all experts at writing a custom estimator. And if somebody ask you if you're a machine learning expert, you can say, I know how to write a custom estimator. And I wanted people to leave the room now feeling like they can, if somebody mentions this at work, they can participate in the topic. And if they encounter it in an interview, they at least know something about it, or at a technical conversation at a conference. And this is a slide that I have to credit my colleague Penelope that she made, so it doesn't fit the rest of my design. She gave it to me. And one very valuable thing on the slide is this MOOC here that is made by some of my colleagues. I don't remember who it is, but Arturo made it. Okay, thank you. It's great for learning a lot of the concepts that I mentioned. I don't think you learn how to write a custom estimator, but you learn a lot of the build-up until then. And it's nice and comprehensible. Thank you. That is my LinkedIn. I write some blogs, but I didn't want to overwhelm you with links, so they're in my description over there. Thank you. Yes, I forget that. Yeah, I was granted 2 questions because I know I was rushing a bit. Thank you for your patience. Presenting code is hard. You can ask me anything about anything that was there, even Fairlearn or whatever, contributing things, or I don't know. But it's also okay if you don't have any questions. It's a lot to take in. Yes?
Yeah, can I ask a question? So would it count as a custom estimator if you do something on top of an estimator? If you want to, let's say, enhance an existing one and still put it in a nice way, let's say, so following the standardized structure, and you use, so we have there the equidal distance or whatever, there you insert a already existing estimator, but you add other things on before or after, maybe pre-processing, or maybe to enhance the algorithm, maybe to add an additional condition to some optimization or something like this. So would it be possible and easy to extend this, or would one need to start from scratch?
Yes, the question is if it is a custom estimator, or it counts as one if you use an existing one and enhance and do something before, after, or something with it. So there are. Have you used the pipelines, for example, in scikit-learn? No. Okay, that would have been a good example. Yes. Remember, I think a few slides ago, if we can go back, I mentioned the meta estimators, and you can use this interface that I mentioned, and inside of it, you can have predictions that come out of one estimator, and you can line up pre and post processing steps and use them with this kind of interface to look like one estimator, and then you can integrate that into pipelines. Yeah, so yes, the answer is yes. Anything else?
There's one question online.
Yeah, ask it.
Camilla asks, what AI ML concepts do you need to know to get into scikit-learn?
To contributing or in general? That is, I think, an important distinction.
Yeah, I understood initially contributing, and I said to join our Slack. So maybe you could cover more about like using scikit-learn. So what's a good entry point?
I think, so the question is, do I need to repeat it, right?
They will have.
Okay, so the question is if, what do you need to know before you get into scikit-learn? And one thing I want to say then is that the scikit-learn team really cares deeply about documentation. There are a lot of examples, more always coming. And just by reading the documentation, you might get familiar with a lot of machine learning concepts that you don't know. So you don't have to be a machine learning expert neither to contribute or to use the library. You can learn as you go. And depending on your use case, you probably need more to be a domain, to know your domain rather than scikit-learn. I think by using the documentation, going over to the places where you can communicate with people that make it and so on, where they can help you, you will figure it out. You don't have to have a deep machine learning knowledge to start using it. I don't know if that's enough as an answer. Okay. Do we stop it? We stop it.
Yes, we, like, 'cause we have
Okay.
to do this. Thank you so much, Tamara.
Wow, thank you. Okay. Hi, everybody. My name's Helen. Today, myself and my colleague Claudia are going to be discussing how we at GLS Studio are predicting delivery risks using various machine learning techniques. To give you an idea of what we're going to be covering today, we're going to be looking kind of in two parts. So firstly, I'll be covering who we are at GLS Studio, what we do, the products that we offer, zooming in slightly on the topic of reclamations in general, which may sound a little bit foreign, but you all definitely are familiar with them. And then going even further into what we call the Reclamation Radar, which is our latest offering. And then in part two, Claudia is going to take the mic and be discussing Streamlit, which is a really, really interesting tool that we find ourselves utilizing quite a lot for sort of ad hoc analysis and that kind of a thing. So firstly, let me show you, here we are. Yeah, so this is part of the GLS Studio team. Studio was founded officially in January of 2023, so still a very, very young team. We are officially part of the GLS Ecom Labs, so basically a branch of the GLS Innovation Unit, so to say. There are just about 16 of us, although we are, as you saw, adding 2 more very soon, hopefully. And we kind of come from all 4 corners of the globe, so a very, very international team. When it comes to the products themselves that we offer, there are 3 core ones at the moment. Firstly being Parcel Planner. So Parcel Planner essentially optimizes sorting operations within GLS postal depots. And then we have GeoMotion. So GeoMotion is a really interesting one. It essentially covers last meter navigation. It takes the sensor data from the hand scanner that the delivery driver uses and takes that data in order to improve and advise future delivery routes. So the same hand scanner that you awkwardly sign whenever you get a delivery and it looks like a toddler has signed their name, that hand scanner can be used to, for example, if a delivery driver is making a delivery to a business in a retail setting, it doesn't really make sense for him to park in the customer car park and go in the main front door. Maybe there's a more suitable loading bay around the back. GeoMotion is capturing this data and is utilizing it for the next time there's a delivery to this address. Then finally, we have Trust Courier. Trust Courier is used to detect and to fight parcel fraud. So we have various pattern recognition techniques that are used in order to notify depot managers in the morning before delivery goes out that this could be potentially suspicious and maybe we want to take a look at it before we take it to someone's front door and they may not be the correct recipient of it. The world of fraud, as it were, brought us into the realm of reclamations. So when we talk about reclamations, we're talking about complaints. So whether you picked up a parcel in a parcel shop and the staff there were particularly rude to you, or whether your parcel arrived damaged, or whether your parcel didn't arrive at all, you make what's called a reclamation, so a formal complaint. We found that the average reclamation, regardless of the severity, typically demands about 29 minutes of manpower or sort of employee time. So this consists of the customer support staff who are registering your complaint. They then maybe pass it on to the depot manager who investigates, who then has to go to a subcontractor and interview them and find out what went wrong. And all of this time builds up very, very quickly when you consider the scale of GLS and how many complaints can happen in a given day. Not only is it time expensive, but it's financially expensive. The average reclamation costs about €10 each to handle. And in the event that it gets escalated to what we call a claim, those then explode in terms of expense. So in the millions when it's coming to settlements and when it's coming to the operational costs associated with those investigations, it really, really balloons very quickly. And we recognize that these claims often stem from what we consider to be preventable causes. So things like loss or incorrect deliveries or damages. There's a way for us to intervene before these happen and to prevent the reclamation from happening, the spend of manpower, the nightmare and headache for a customer. So that is where we decided to introduce the Reclamation Radar. So what the Reclamation Radar is, it's essentially a branch of the Trust Courier product that I already spoke about, and it flags high-risk deliveries based on prior reclamations. So depending on the frequency and the severity of a reclamation, points will be assigned to new deliveries to that address. So it's taking in that historic geospatial data and using it to create a smoother delivery experience for the driver and for the consignee, the recipient of that delivery. And by doing so, it allows the depot manager in the morning, before those drivers go out for the day, to intervene and maybe warn a driver that, hey, there's been a lot of lost parcels here recently. Maybe you might want to make sure you get a signature this time. Or this is looking a little bit fishy, and I think I actually want to stop this parcel entirely. We then decided that we want to, on top of this, reinforce the point system that we already have by developing a more automated process of flagging these high-risk deliveries, and that is through a machine learning classifier. In this case, we're using XGBoost, and we're feeding it multiple factors such as parcels specifications, like the weight and the volume of a parcel, driver factors, like maybe this particular driver assigned to this parcel has received multiple complaints lately. Geospatial factors, sequencing factors. When we say sequence, we mean the order of deliveries in a given day, like the route that the driver has taken. All of these get thrown into this classifier, and it will spit out a binary result, whether we expect for this particular delivery to be risky or not risky. And then based on that, we will be implementing the result in our front end. You can see here on the far right, we have our Regeln, or our rules. These are the culmination of factors that determine the points or the sort of risk score that we assign to an individual delivery on a given day. And I'm going to pass on over now to Claudia to discuss part 2.
All right, thank you, Helen. And yes, before starting the part 2, which will address probably a very common struggle for data analysts. I don't know how many data analysts sit here, but for sure, something like very common happened to you. So you have written a fantastic Python script and you need to showcase it, most probably to someone who doesn't have any experience with it, is not like a Python user, or doesn't even know like to open like operate a Python script. And in this case, like we are talking about situations where like we like the most common visualization tools or BI tools are not effective, for the reason that maybe they don't support fetching data from different or multiple sources, so different databases. When we want to load a machine learning model, and in this case, we want to run in prediction or call also other functions that we custom made for that specific project. And yeah, as I said before, we want to share these results. So we want to say, okay, don't just like look at my GitHub repo, but actually give something where your, I don't know, product owner wants to interact with that. And yeah, why not making it interactive? So in our team, we often use the Streamlit app, which is basically turns Python scripts in very easy and customizable web apps, where you don't need to bother any of your web developer front-end colleagues. The upside is that it's open source. It allows you to create like interactive visualization and dashboards through interactive widgets. It's interacting very easily with other Python libraries such as Matplotlib, Seaborn, Altair, and so it allows also for you to make interactive visualization and filters. And what I find it the best is that while you code and you create your script, you can see all the updates that you are making on your scripts without having to push your changes, but you will actually see directly all the changes on the interface. So what I wanted to create was like something that will allow, so the like a step backward. We needed to showcase a couple of projects for our team review, and like we wanted to put together two big projects. One were the preliminary results of the machine learning model, and the other one was a statistical model that we created to actually estimate the value of a parcel, just like looking at few factors. And what I wanted to allow my user was to pick a date, select a parcel that was delivered on that day, and that getting some instant insights of those that I was mentioning before. So knowing the estimated value, predictive the delivery risk, and check also what was the outcome for that day for that parcel. So just like a few technical details about how we can create our layout and improve the performances of the script. So what I found very nice about Streamlit is the fact that you can use like a couple of built-in functions such as ST title or ST select box, and you can create like your title, or like you can customize your layout. And with select box, you can create like drop-down menus where like selecting, for instance, the result of another function. And what is even best is like the part where you can improve the efficiency by caching. And I wanted to show just two examples. One was the part where we can cache the resource. And this was the case of like these two models or script that one is exactly like one of the trial of the model that was made with a random forest. And then you load also another function through a function, another model, this statistical model that I was talking about before. And another typical problem is performances. So let's imagine you need to fetch data from your database, and you need to load the data from a very big table. And you want also allow the users from time to time to play around with these drop-down menus, but then every time, like as much as you can improve your script, your data will have to be fetched again, and then you will have to wait time and letting the query fetching the data from your database. So you can actually cache the results, and it's with using the other decorator down below, which would be SD cached data, and you can set for how long your data can be cached. Here, for instance, I just wanted to cache it for 10 minutes. But let's just go quickly into the app itself. So it's very easy. So you get your script, you open. Oh, sorry. How do you do that?
Just grab the top and pull it to the right.
Would you want to mirror?
I want to show this other slide.
Okay.
Yeah.
Yeah, I think. Oh, where's the slide?
Maybe make this one, not full screen.
If we pull this down. Oh, I don't know why your Python isn't coming up. Yeah, can we disable the mirroring?
Yeah, go up to. Or we want to enable mirroring, right?
Yes,
Yeah.
sorry.
So go up
Oh,
here
it's
to
here,
settings.
Oh, it's coming. I just don't know if it's gonna open the. Okay, we are gonna do it from here. Yeah, so you want to open your terminal, and you just want to run the command Streamlit run within the path where your script is, and this will automatically open your app that will be locally hosted. You will allow your two-factor authentication. Yeah, so with this decorator, like the script will basically telling you what's going on, yeah, and loading the rest of the the interface. So you have a drop-down menu with, well, the last 5 days from when we created that. You will have the parcel number. Both of them are now loading the data backend and applying the model. So you can choose from the drop-down menu, like the parcel and the data that you want to see, and then you will automatically have like some details about the parcel, including also the estimation and the factors that we were talking about before that we input into the model, and then you will have the sort of like outcome prediction. So in this case, we don't see any risk, and check it against the actual outcome of the delivery for that day and that parcel that in this case was successful and it was delivered. How does it work? Right now, like the app is just like shared locally, but let's imagine you want to create something that is more like more complicated than this app. You want to push your repository to GitHub. You connect it with a Streamlit cloud, and then you will just share the link with the app, and that will be available for anyone to use it. Yeah, so that's basically it. I hope this little showcase was like inspiring for anyone who like didn't know this library. And yeah, thank you for your attention. Any question? Yes.
I have a question. So you were talking about high-risk areas.
Mm-hmm.
So what happens when someone is in a high-risk area? Like the parcel doesn't get delivered at all, for example?
No. I mean, for high-risk area, we mean like situations. So in the reclamation radar, we have historical data of addresses that had been flagged with reclamations before. So this is what we consider, let's say, high risk, but it's not just like one reclamation that will give this a high risk, but like maybe more than one reclamation that happened on the same address. And this will not just stop your parcel to be delivered that, but just like allowing the depot manager to maybe take action and then enforce on maybe like during the delivery, like the signature of the recipient to be sure that the parcel has been delivered, or just letting know the driver that in this on this address maybe there were like delays in the delivery because of, I don't know, construction sites or whatever thing might have happened in the past. Does it answer your question?
I'm wondering what then happens. So like if it's a high risk area, so like for example, if there's a construction site,
mm-hmm.
do parcels then not arrive at all? Like do they get deviated to like parcel state?
No, it's, I mean, this will be a warning for who delivers the parcel.
Like around the construction site, for example.
No, but they will just have it into account that on that address there might be, construction site, or I don't know, like if it depends on the type of the reclamation as well.
So I think at the moment the most heavily used feature is Inform Driver, and it's essentially providing a platform for depot managers to in a more streamlined way perform lots of actions that they were already doing in a much more manual way with printed out pieces of paper and going to drivers directly. And so what a lot of them are depending on is Inform Driver. So I've recognized that there's repeat traffic issues in this area. There's repeated reclamations related to late deliveries in this area. And I want to inform the driver. I want to let them know that I'm aware of this issue, that it's come up on our radar, and that it's something that we want to address because customers aren't happy about it. So I think at the end of the day, what it boils down to with the reclamation radar was an improvement of quality in terms of driver efficiency and in terms of customer satisfaction. So it's never about intervening and kind of blacklisting areas or anything like that. It's about equipping drivers with more information than they currently have, because right now they kind of go out a little bit blind in terms of the areas that they're delivering in, and it gives them a little bit more in their arsenal to work with, I suppose. And yes, there's another question.
Hi, thanks. You kind of answered my question already. I was going to ask about data and ethics and what kind of data you thought to include or not include based on those kind of considerations. It sounds like you thought about this quite a lot. So maybe you can comment on something else I'm interested in. It sounds like you know a lot about the domain and how the how things work at the depot. Did UX research or interviewing the delivery drivers and the depot managers and whoever, was that an important component of your development process, or did you already have someone on the team who was an expert in the area? Maybe you can comment on that.
Yeah, I think absolutely. I think it's absolutely unavoidable when working either with BetterMile or with GLS Studio to become a domain expert yourself. We all participate in depot tours, for example, when we join, so we get a kind of finger on the pulse of the real people who are using this product. I think it's very easy to over-intellectualize and get overly caught up in all of the small details and forget the real use cases of the real people who are depending on these products every single day. So yes, we do keep very constant communication and have very strong relationships with, to be honest, every depot, but a handful of pilot depots that we have sort of power users in, who we depend on for very regular feedback. It's definitely very, very important. Yes,
maybe one more.
Thank you for the presentation. Can you please skip to the next slide? Yeah, that's clear. So we have different different parameters, and do you have any relation with all these input parameters? Do you use some algorithm for the predictions, or how exactly it goes to this XGBoost classifier and how it affects the output?
So far, we have run like few attempts for this model, and the part of like feature engineering the inputs is like still the most sensitive part, and that highly affect the outcome and of the model itself. For now, like the part of like feature engineering the data is not requiring any extra like model on top. So for now, like after having fetched the data, pre-processing, engineering them and pre-process them, like we just feed it to the model.
Am I allowed to have the following question?
Yeah. Maybe we do follow-up questions as part of the networking because of time restraints, if that's okay. So we'll just close up for the stream, and then we still have some time here in the space, and maybe we can then continue as long as that's okay with the speakers.
Yes.
So yes, thank you everyone. I'm still just going to talk into your machine, sorry. Thank you everyone for attending this evening. Thank you for our amazing speakers, both Helen and Claudia, and Maren and Tamara and Stephanie. It's also really exciting to have one of our youngest PyLady members join, Stephanie's daughter. So that's very exciting for us. And of course, to all of you as an audience. I also want to say a big thanks to BetterMile, especially to Vitalia for hosting us and for reaching out to host us and then being so supportive. So if your company could do the same, feel free to reach out to us. The best place to find out about PyLadies is on our Slack. So if you're not there, we've mentioned it many times this evening, you have no excuse, please join. And as I mentioned, the video, sorry, I didn't mention this yet. I wanted to mention the videos are on YouTube, so you can also see previous talk evenings as well as this one. And we have some more time still in the space to get to know each other and network a bit more. So thank you very much.